Welcome back to the Advanced Microcontroller series. In this session, we are learning about microcontroller interfaces with up counter on SSDs. And here is the agenda: Introduction, Design, Circuit on board. What is up counter? An up counter on a 7-segment display is a digital circuit that displays numbers from 0 to 9 in increasing order. So in this session, let's do the project. It will display 0000 to 9999. So up counter, right? So 0000, then 0001, then 0002, like that up to 9999. So after each maximum value, it resets. Then it starts printing from the 0000. Then it will continue same 0001, 0002, 0003, like that. See here, we having 4 SSDs. Each SSD is having control lines. So these control lines are connected to the port A from RA2 to RA5, and data lines are connected to the port D from RD0 to RD7. So this one we already discussed in the previous session, so I am not going to explain it again. So here you can see 0x3f. This one also we discussed in the previous session, so I am not going to explain this again. So here you can see data lines connects to the port B, control lines connects to the port A from RA2 to RA5. SSD of maximum SSD count is equals to 4. So SSD of SSD0, SSD1, SSD of 2 and SSD of 3. So this is the code which we written for microcontroller interfaces with SSD. So here you can see maximum SSD count is 4 and SSD data lines connects to the port B and control lines connect to the port A. So this is the data direction register of port D and this is the data direction register for port A. Yeah, this is 0 to 9. So this one we already discussed in the previous session. So okay, main.c. So here you can see static void init config of void. So here you can see function call init SSD off. So it will comes to here and this function will be executed. What is there inside this function? See here, setting the SSD data line as output. Here you can see clearing the bit 0x00 and here you can see setting the control line as output. So the same thing, this is what data direction register. See here SSD control port and 0x03. Why 0x03? Here we having 4 control lines that is connected from RA2 to RA5. Wide display of unsigned char data. So here you can see for loop, when digit equals to 0, digit less than maximum SSD count, that is 4, then digit value will be incrementing. SSD data port equals to data of digit and control port equals to control port and 0x03 OR operation, this one, and here you can see shift operation 0x04 shift and this is digit, and here you can see this for loop is written for delay. this is the code. So here you can see unsigned char SSD of maximum count, and here while, so it prints the 8051 on SSD. But in this project, what our aim? So our aim is to print 00002 9999, not hard code it is. Okay, let's modify the code. So in the main.c, so here I am going to modify the code. Sorry. Unsigned, for counter what is required? Unsigned int count equals to 0. Then we need some delay. Yeah, that's it. Next, unsigned char digit. So inside this I am going to write the digits from 0 to 9. Yeah, that's it about the declaration. Sorry, this it should be char is a data type. So inside the while loop I am not going to write any hard code like this. So here inside the while loop, so if delay minus equals to 0, then delay equals to 1000, then count value increments. So when it reaches the maximum value, count reaches the maximum value, that is 9999, it resets count equals to 0. Yeah, that's all. So now I am not going to write any hard code, right? So what we need to do? We need to extract without using the hard code. So how to extract? So here 1 2 3 4. So this is the modulo 10 is equals to how much? So what is modulo? So here we use a modulo, right? That is nothing but what? Percentage symbol. So sorry, not here, this one. So what it means? So why it is used? So this is nothing but modulo. Modulo operation gives the remainder after division. Okay, 1 2 3 4 modulo. Okay, I'll explain it here. 1 2 3 4 divided by 10 means how much? 1 2 3 4. So what is the remainder? Remainder is 4. So that is nothing but modulo. So remainder is nothing but modulo. So here we got 4. Okay. Then 1 2 3 4 modulo 100 means how much? 34. Now 34 3, 4 divided by 10. How much? 34 divided by 10 is 3. Yeah, now we got 3. Here we got 4, 3. Next 1, 2, 3, 4 modulo 1000. 1, 2, 3, 4. Sorry, 1000 means how much? 2, 3, 4, isn't it? That is divided by 100 means how much? 2. Here we got 2. Now 1, 2, 3, 4 divided by 1000 means how much? That is 1. So here you can see 1, 2, 3, 4. It is not hard code. So now instead of writing 1, 2, 3, 4, here I am going to write count in the code. So here SSD of 0 equals to digit of count divided by 1000. Yeah, that's it. Similarly, we need to write for next. So here you can see it showing error digits. Okay, either write digit or digits. So here I am going to copy this and I'll paste it here. So SSD of 1 means what? Digits of count modulo so that is divided by 100. And same thing, SSD of 2 digits, here we need to use modulo. Here we need to write 100 instead of 1000 and divided by 10. And SSD of 3 digits of count modulo 10 modulo 10. Yeah, that's it. Next, display of SSD. Now save the code, click build. The project driver is empty. You will need to add a file to the project before you can build. Okay. This is there. Okay. So okay, I'll do one thing. So copy. I just quit this and I'll reopen it. MPLabXID. So in this project we are going to print 00002 to 9999. So yeah, at the same time I am going to open PICSimLab Simulator. So yeah, okay, so here project. Opening. So it's embedded electronics. Yeah, it's already build. Yeah, see here, build successful. Now open PICSimLab Simulator. Then here it is PICGenios and PIC16. So here PICSixteen-F877A Microcontroller, and here you need to select 20. Yeah. So here load text. This one not required, and even this not required. See here 00001, it's printing, right? But it's taking some delay. Okay, so go to the code, and here just I'm changing this value and click save, then build. Build is successful. Go to the PICSimLab Simulator, reload last. Sorry, still taking delay, right? See 0 1. Okay, I'm changing the value again. So here I'm changing this value to 40. Okay, save, build. Yeah, go to the PICSimLab Simulator, click file, reload last. Why it's taking delay still? It's printing from 0000, then 0001, 0002, 0003, like that, up to 9999. After it reaches 9999, it resets, then again print from 0000, 0001, 0002, like that. So see here, it's printing fast compared to the previous, isn't it? So that's all about the microcontroller interfaces with up counter on SSD. For more projects, please watch the upcoming videos. Thank you all.